Welcome to our trig tutorial, and on this particular day we took notes over trigonometry, and in class we picked up trigonometry worksheet number 15, and so we will be discussing how to do these particular types of problems. So we're going to be taking our trig notes, and that's going to be page 16. Our lab tomorrow is going to be page 17. Suppose that you are at a Sequoia National Park, and one of the reasons why it's called Sequoia National Park is because it houses sequoia trees. They are the biggest trees in the world. But think about it for a moment. If you see a tree like this and you wondered how tall is that, how would you figure that out without any type of ladder? But if you did have one, that'd be an awfully tall ladder and scary, or any type of lift. So I want you to kind of be pondering that. You can pause if you want, but this lesson is actually, and this question is actually here to let you understand that there is practicality in trig, i.e. physics, and that it does allow us to be able to find things out that we would wonder about, like how tall is a tree. Trigonometry is a branch of mathematics that deals with the relationships between the sides and the angles of triangles. It surrounds us. It is all over us. As you can see, the fella that's just leaning up against a tree on a nice, maybe summer, cool fall, fishing. And you can see all these angles around him and his pole and the ground and the tree that he's laying against. So it is relevant. The first thing that we need to discuss and remind you is the parts of a triangle. And if you look at this particular slide, you see the alligator in the background. And the alligator is just representing a little cartoon or a funny way in which to help you remember this if you were forgotten or if what you learned was a little bit difficult for you to begin with. So if you look at the little green alligator, or actually he's kind of big, in the background, you can see that his eye kind of lines up with the corner of his mouth. And there we have drawn a purple triangle. So the head of the alligator is referred to as well, or is equal, or as significant of the side of the triangle. That's called the hypotenuse. You can see that at the corner of the alligator's mouth that there is this little circle looking sign that is called a theta. It's a Greek letter, and that's the sign that we use to represent angle. That angle that is in question is going to be near the adjacent. So the angle is going to help you identify the adjacent. And then across from the alligator's mouth, we have the little person here who's saying, "Oh no," and his little head is in the shape of an O, which represents opposite. Now, if the alligator cartoon thing does not work for you in helping you understand this, I want you to notice that there is a right triangle in here. And this right triangle is going to help you identify your hypotenuse. So your hypotenuse is opposite your right triangle. Now, how do I know that one or the other is going to be O or A? Well, in this particular example, it tells us that our angle of question is right there in that alligator's corner of his mouth, which is going to make that the adjacent, because the adjacent means next to, therefore it's adjacent is next to the angle. So angle starts with an A, adjacent starts with an A. So in order for you to be able to identify such things, you are going to have an identified angle, and it's that angle that you're going to be using as a reference to decide who's going to be the opposite or adjacent when you know what your hypotenuse is. Okay, and remember your hypotenuse is always across from the right angle or the 90-degree angle. Okay, so moving on to our next slide. Hopefully, there we go. The Pythagorean theorem is going to be very important. Actually, it's pretty easy, and you'll have some easy questions in your homework. But the Pythagorean theorem is when you're looking for one side of the angle or the triangle and there's no information about an angle, but you have some, at least two for a side, you can use the Pythagorean theorem. Notice here that it is c squared equals a squared plus b squared. C always represents the hypotenuse. The hypotenuse is always the longest side of the triangle. Also, it's the opposite of the right angle. Notice that the right angle is composed of the side B and the side A. Now you can always label side B and you can consider that your opposite and side A your adjacent, but in the end it isn't really going to matter which of those two sides that make up that right triangle are A or B. So if it works for you to remember it this way, then you can stick with that. That brings us to trigonometry. So SOHCAHTOA TOA is our acronym that we use to help us remember the formulas to calculate the side if we're given an angle and the length of one of the sides of a triangle. Now remember, the Pythagorean theorem, we have to have two known lengths of the triangle of two sides out of the three. SOHCAHTOA or trig comes into play when we are given an angle and one side. So here we have the functions of trig of sine, cosine, and tangent. And just remember, when we are given one of the sides of a triangle, the length of it, and we're given an angle, we can use one of these three. So how we determine which one of these functions that we use is going to depend on the information that we're given. If we are given an angle and we are given the opposite and we're asked to find the hypotenuse, well then we would use sine of the angle equals O divided by H. Okay, so that's how we're going to know which one of these that we're going to use. So for example, if we're given an angle and we're given the adjacent, okay, and we're asked to find the hypotenuse, then we use cosine of the angle, A divided by H. Or what if we're given an angle and we're asked to find O and we're given the adjacent, then we would use tangent of the angle equals O divided by A. So let's do an example here so that we can understand this. Now, my example 1 is actually your example 2 on your homework. So just so that you know, that's kind of what we're dealing with here. So in this particular example, it says we're walking up a hill that is 500 meters high. So if you will, here is a hill right here. And it tells me that my hill is 500 meters. Sorry, I messed up that. It's a 500-meter hill. Now, we're going to have to remember to use our units these days. Now, remember that hill has like an incline to it. Most hills do because we can't get from here to here, really, unless we're a lemur. No, not a lemur, a gecko. So in order for us to travel to get to the top of that hill, we've got to go up this hill's slope or incline. So it says here in the second sentence that the trail has an incline of 12 degrees. So it tells me then that when I look at this right here, my slope, that's going to be a 12-degree angle. And so I'm going to draw myself a little invisible line, and that's going to represent my angle. And we down here, now we have three sides of a triangle. So if you look for your right angle, here it is, right here. So opposite your right angle is your hypotenuse. And you're being asked to find how far you're going to walk to the top of that hill. So we know that that's the hypotenuse. So I am given the hypotenuse. Well, look at where my angle is of which it's given me. Well, the angle is 12 degrees. So what that means is I have an adjacent side to the angle of question, and it makes a 90-degree angle with this 500 meters. So this is my adjacent, and this is my opposite, and that's how I figure that out. So with that information, I now can take a look at one of those three formulas that you should have written down from our previous page. Notice that I have O, and I want to find H. So which formula has a relationship between the opposite side of a triangle and the hypotenuse side of a triangle? That would be sine of the angle equals O over H, or so. So I have to find H, so I'm going to solve my problem trying to find H. I got to divide both sides by sine of the angle. And so I end up with this formula. And when I plug it in, I'm going to put 500 meters over sine of my angle, which is 12 degrees. And I put that in the calculator like this. Okay, so here's my calculator. Sorry, I had a little bit of trouble there reaching it. And this is what I do. I put my 500 in, and I'm going to divide it by sine. There's my sine button. I got to put my angle in there. And that takes care of all the parentheses for me, and I get an enter. Now, I would ask you to write your answer as a whole number. So 2,405 would be what I would want you to give me for a question like that. Okay, so we can clear that. All right, and we can move on to the next question. So that was a situation where we were given a angle and we were given a side, so we had to use one of our trig functions. Now here are the formulas that we would use when we're trying to find an angle. So when we're trying to find an angle, we're still going to use trig. So in this situation, we're given uh, the sides, two sides of the triangle. And we can use two sides of the triangle, whether it's opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent, to find that angle. We just are going to use the inverse of the sine, and I'll show you in the calculator how to do that when we get there. Now earlier I didn't tell you this, but here on the bottom, and you can't see it because my little recorder thing is kind of covering it up. Let me see if I can move it. I can't move it, sorry. But it says we need to make sure that our calculator is in the mode of degrees, okay? So we want our calculator to be in the mode of degrees. And I will show you how to do that. So here's the calculator. And you want to hit mode. And you want to take this little toggle switch right here and go to radian. Go over to degree, you hit enter, clear, and you're ready to go. Okay, so anytime we're dealing with cosine, sine, or anything, our calculator needs to be in the degree mode. So let's do some examples here. Now, we have this nice little picture already drawn for us. It tells us that the ladder itself is 20 meters long. You can see it's already labeled. It's leaning up against the building. It's going to rest on a wall that is 10 meters tall, or 10 meters above the ground. We want to know what the angle that the ladder makes with the ground. So that angle in question is going to help me identify whether I label this adjacent or opposite, because the angle in question, which starts with an A, also is the adjacent side of the triangle. So we always know that across or the opposite side of the right angle is always the hypotenuse. So now we're left with the opposite over here. And so now we can move forward. We got information that we need. So we have the H and we have the O. So out of the formulas that you wrote down in the previous page, hopefully you're writing this stuff down. But out of the formulas that you wrote from the previous page, which one has a relationship with hypotenuse and adjacent? Not adjacent, opposite. It's angle equals the inverse of sine with the opposite over the hypotenuse. And so we don't have to do any rearranging. 10 meters, 12 meters. We put this in our calculator. And remember, our calculator must be in mode degrees mode. So I'm going to go to the second button and I've got to push my sign. And I don't have to do any parentheses stuff because it does it for me. I just put it in like I see it. And I get 56 degrees, and that's what I would ask you to give me those that whole number there. I don't want any decimals as long as there's 2 in front of the decimal. As long as there's 2 digits in front of the decimal, I'm happy. And since that is 56.4, the answer that I would want is 56 degrees. If it was 56.5 something something something, then it would be a 57 degrees. Okay, so we'll clear that. Let me get this erased. My computer seems to cooperate better with me whenever I erase the writing that I have. Otherwise, it doesn't want to go to the next problem. So, example 3 is example 3 on your paper. You probably figured out that example 2 on my PowerPoint is example 1 on your homework paper. So example 3 is asking me 2 things. First, what is the distance across the lake? So if we look at our lake, we can actually